It says recording is started and whatnot. Give me a thumbs up. Okay, great. So let's quickly jump straight to the questions. So if I'm sharing my screen and my recording is up, then we can get to the business of the day. So this is the easiest question. Obviously, there is going to be a question on graphing. I'm going to take a rough guess. So you should be able to do these kind of questions. So earlier we did a similar question, and we will also look at this question now and see if we can be able to answer it. Let me expand the screen on my right, which is where I'm writing. So let's leave this the first page. Let me write signals here so that I do not confuse it with other mini notes of mine, which I have here. So signals, let me say 9 p.m. Okay, so let's quickly jump into the question right away and see what we need to take away. So if you look at the graph, they are saying this graph is described by x of t. So the first thing they're expecting you is to find the equation for x of t, and then we delay it by time t. So I'll come here and say graph sketching. So if you look at what is going on, let me quickly draw a rough sketch so that I am able to choose what is going on from my side. So let's narrow that and zoom in the graph a bit. So if you look at what is going on, we have a signal. Use this color. We have a signal. We have 1 and 2. The signal is going up. Let's put that as 2. And then let's draw another line which goes straight. And then down there, it is at 7. And then here it is at 4. Let's extend that one, and then let's use purple. It goes straight and it lands at 8. And this is obviously t. So if you remember from earlier, what you need to be able to derive here is the equation for the blue line. Okay, so if you look at the blue line, let's call it y1. We need to find that equation. And then the gray line, you look carefully, it's going to be a unit step. Let me call it y2. This gray line, and then I'm going to have the purple one. And that purple line, we'll call it y3. So we need to find y1, y2, and y3 for us to even start working. So if you look at y1, we can all agree that y1 is a straight line. So for me to be able to find what equation this is, I need the gradient. Because if you look at y1, it is obviously going to be m1t plus c1. So I need to find the gradient m1. And as you remember, gradient is change in y over change in x. So if you look at these 2 points here, this point here is at 2 and 0. That point there is at 2 and 4. This one here is at 7 and 2. Okay, x is 2. It's the other way around. Sorry. So if you look at this point here, the x is 4, the y is 2. Then if you look here, the x is 7, the y is 2, and that last point there, the x is 8, the y is 0. So we can easily find the gradient of m1 because we have the 2 points. And you should remember this Gradient is change in y over change in x. So we have y is 0, y is 2 minus 0 divided by the x. We have a 4 there, and then the bottom we have a 2. So this will give us a 2 over 2, giving us a gradient of 1. And that is for M1. And then obviously we know that our Y1 should be our M1, which is 1 times T plus C1. Then for us to find the C, we can use any point. So we can use the 4 and 2 point. So Y is 4, where Y is 2, where T is 4, plus C1. And if you look carefully here, your C1 will simply be -2. So therefore, the Y1 will simply be T minus 2. So there you go, that's your Y1. So if you look at Y2, all what it is a value which is equal to 1. Okay. There's a value which is equal to 1. We'll quickly come back to the restrictions shortly. So let's go to Y3. Y3 should obviously be M3 T plus C3. So you can see that Y3 is also a straight line. So let's go and find M3. M3 will be change in Y over change in X. We have 2 points there along the line, which is purple, which is Y3. So the change in Y can be 2 minus 0 divided by the change in X is 7 minus 8. So the answer we obtain is -2, is the gradient. So if you quickly find your Y3, it will be the gradient, which is -2t plus the constant C3. And then we can use one of the points which are on the line. We can either use 8 and 0 or 7 and 2 in order for us to find what C3 is. So I'm going to use the one which is 8 and 0. So Y is 0 and X is 8. That's C3. So if you look carefully, our C3 will simply be 2 times 8, which is 16. So therefore, my Y3 is simply -2t plus 16. So I now have all my equations. Now I need to write the final expression in terms of the unit step function. So let's copy this here. And paste it here on the next page. Right here. And then let me copy my Y1, which is that. And let me paste it here below. And then where's my Y2? Let's paste it here. Then lastly, let's paste our Y3. And we paste it here. So there you go. That's our Y1 and Y2 and Y3. So our X of t will be equal to, which is the overall signal combined. Our Y1, look at our graph Y1. This graph is there between t is 2 and t is 4. So my graph Y1 is between u of t minus, it is between 2 and between 4. That's where we have the graph Y1. Okay. And then let's look at Y2 plus Y2 into Y2 or the value 1, the graph has a value 1 between 7. So we are going to go to t is 7. That's your y2 graph. And then your y3.
How did you get 1 for y2?
Y2
It equal to 2.
it's supposed to be 2. Thank you. Look at the value of y2 here. It's supposed to be a 2. Let's quickly fix that. I love the unit step function a lot. It's supposed to be 2. It has a value which is 2. Thank you. So y2 has a value which is 2 between t is 4 and t is 7, as you can see here. And then let's quickly go to y3. We have the graph y3. I'm going to say plus. I have y3, and y3 is between my t is 7 and my t is 8. That's where the graph y3 is. So I can now substitute the respective values which we have found, and then we can now start doing the shift and everything which they want. So therefore, my x of t will be my y1 we have computed. It is t minus 1. Doesn't change. It is between t is 2 and t is 4. And then my y2, I will add it here. My y2 is a graph which is valued 2, and this is between t is 4 and t is 7. Then the last one, y3, plus the function for y3 we obtained as negative 2t plus 6, starting from t is 7 to t is 8. And there you go. That's your x of t. And then now we can start stressing about doing what they are saying we should do, but at least we have our x of t. So this is the first step. So if we look at the question now, they are saying,
So I
I
just
think
wanted
you made
to
a
ask
mistake.
for y1, yeah.
You
y
accidentally wrote -1 when it was supposed to be -2.
minus 2. I'm glad that there's people who are awake in the meeting. Maybe I'm tired 36 hours earlier. Anyway, thank you. So please make sure that you double check I do not make any mistake here. So I'm happy if we have people who are looking at what I'm doing carefully. So this is our x of t. So for A, they are saying sketch. So let's quickly go for A. So for A, they are saying we should sketch the delayed x of t by 2. So all what that means is we have x minus 2. So which means they're saying we should sketch this function. So the first thing we can do is we can go where we see t on our original function. You have two options. You either go straight to the graph which has been drawn, and then you just shift it by 2. Every point you shift it by 2. Or alternatively, what you can do, you can rewrite the new expression and then draw the actual graph. So we have two options. So let's quickly find x of t minus 2 first. So let's compute x of t minus 2. All what this means is that wherever you see t, we will put t minus 2. So open bracket, there we have t. So we're going to have t minus 2 minus 2. And then we have u of t minus 2 minus 2 minus u of t minus 2 minus 4. And then plus 2 into, we'll write this down here. It is u of t minus 2 minus 4 minus u of t minus 2 minus 7. We close the bracket there, and then let's push the last part, which is going to be plus minus 2 into, where we see t, we put 2, t minus 2. So we have t minus 2 plus 6 into u of t minus 2. Yes. Do we have a question?
No.
Okay, no problem. So where we see t, we put t minus 2. So t minus 2 minus 7, and then minus t minus 2 minus 8. Okay, let's quickly copy this, go to the next page, combine it, and then plot our graph.
Yes. Can I see
Yep.
your Y3 there? The Y3. Y3 equation, right?
Y.
Yes, it's plus 16. It's plus 16, but you wrote plus 6 there. Can you see?
Okay, let me quickly scroll up. How did we find 16 plus 6 plus 6? There's a 1 here. And we need to put a 1 here. So thank you. So let's quickly try to organize this expression, and then we go into the plotting. Because if you remember the problem we did earlier, if you were in the session, they said we should sketch this, and we did. So let's quickly rewrite our expression. So if you look carefully, we'll end up having t minus 4 into u of t minus 4 minus u of t minus 6, close the bracket, plus our function is value 2 for u of t minus 6, and then minus u of t minus, that should be a 9. Then we are done there, plus let's quickly do our multiplication and addition there. We are going to have negative 2t. That's going to be positive 4 plus that, it should be 20. And then it is going to start at u of t minus 9, and then minus u of t minus 10. And there you go. That's our function. So you have two options. It's either you can easily use the original graph and do the shifting by 2, or you can redraw the graph as a whole. So let's quickly look at redrawing the graph quickly. Or in fact, let me take the original one and see if we can do the shifting quickly. So let's put the original graph here, and then let me erase, but there's no need for me to erase anything. So remember that we have the original graph here, and they said what we need to do is to do this shift here, which is t minus 2. So the question to everyone in the meeting, the new graph, I'm gonna draw it using, which color did I not include here? Let me take pink. So when we have minus, the question is, are we moving to the right or to the left?
Should be the right.
The right.
Okay, on point. I'm glad we all understand that. So we should move every point to the right by 2. Okay, so which means if I draw a similar graph here, and let me put the 2 here, then let me put a 2 here, and then let me put a 4 here, Let me put a 7 here, and let me put the 8 here. So what we need to do is every point we need to move it by 2 to the right. So the point which was here, originally here, this one, it will move by 2 to the right, so it is here. This point here, which was at 4, it should move by 2 to the right, so I need to include 6 somewhere in between here. So let me have a 6 somewhere here and a 7 here. So look at what is going to happen. So the point which was here at 4, that one should move 2 to the right. It should, meaning if you move it by 2 to the right, it should be at 6, which is somewhere there. This is not drawn according to scale. And there you go. That's the point there, because it should be at 2 also. And then we look at that corner, which is at 7. We need to move it by 2 to the right. So meaning if it was at 7, when we move it by 2 units to the right, here I should have 8, and then I should have some 9 somewhere here. So the point which was at 7, if we move it by 2 units to the right, it should be at 9. So meaning that point is somewhere here. And then the point which was at 8, we move it by 2 units to the right, which means it is now at 10. So we go at 10 and we do that. And then now we can connect our new graph, which is good as done. It becomes that, and that. Okay, so this point here would be a 9 and a 2. This one would be a 6 and a 2. And then this one would obviously be a 4 and a 0. This one would be a 10 and a 0. So this is one easy way. Because it's t minus 2, you just shift every point to the right. Another alternative would be to sketch the graph again from scratch. So let's quickly copy it, and we see how we do that. And you knowing how to sketch the graph from scratch is useful when you are given a complex shift and scaling, because doing it
So
manually.
I think isn't it supposed to be minus 2 plus 10?
Let me see. Minus 2 plus 10. Please shout again. Where is it supposed to be minus 2 plus 10?
It's before the last square bracket.
So
because wasn't it minus 2 times by t minus 2 plus 6?
Okay, let me quickly scroll up there. So plus 6, so it's plus 16. Can you see that?
Oh, sorry, yeah, I left out the one there. Sorry, sir.
Yep. Okay, so what we can do is we have that option of shifting the graph graphically. And then we have another option where we say, so this one I'll need you to look carefully. Let me draw a Cartesian plane. Let's draw it like this. I know already. Let's push it more the side. And then let's push it that side. So I'll draw my, let me see that graph. So I'll draw my, let's say we have a 1 here, a 2, a 3, a 4, a 5, 6, 7, 8, 9, and a 10 there. And then here, I'm just gonna have a 1 and a 2 there. And maybe a 3. So let's quickly look at our graph. So what this is saying is that between t is 4 and t is 6, our graph is supposed to be t minus 4. So if you quickly plot t minus 4 and you find, let's say, the x-intercept where y is 0. So if you look at t minus 4, you equate it to 0, you'll find out that it is crossing at t is 4. And then when you equate the t to 0, you'll find out that it's going to cross at -4. So this graph here will look like this, the first part. So it is going to cross, for a t is 4, it is going to be 0. Let me use pink. At t is 4, it is going to be 0. And then if you remember, this graph should be going like this. It should be going like this. So one of the ways you can use to easily choose your values is you can substitute, because you know that the graph starts at t is 4. So you can substitute t is 4 here, and then you get 0. So you get that point, and then because you are going towards 6, you can substitute t is 5 there, and then you will get 1. So meaning at t is 5, the value of the graph will be at 1. And then at t is 6, when you substitute 6, 6 minus 4 will be 2. So meaning at t is 6, the graph will be at 2. But then we are done there, because we said the graph is bounded between -4, not -4, +4 and +6. So that portion looks like this. And then we go to the second part of the expression, which is that the graph is valued 2 for t between 6 and 7. So it is valued 2 between 6 and 7. So there you go. We are done there at 7. So that accounts for that portion. And then the last portion, which is this one. This graph is valued between, let's quickly see. Is that supposed to be a 7 or a 9? Let me quickly scroll up to -7. And then that is supposed to be -6, -9. Okay. So please look carefully. You should be able to see these things when you made a mistake. Very easy. This is supposed to be a 9 here. I forgot. Instead, I put a 7. This is supposed to be a 9. You'll see when you scroll up on the PDF. We had a 9 and then I substituted a 7. So if you look carefully, it means my function is valued 2 between t is 6 and t is 9. So I need to extend this to 9. That's where my function ends, being valued 2. Okay, and then now we go to the last portion, which is this one. My function will take that form between t is 9 and t is 10. So what you can do to make your life to be easy, you just plug in your t is 9 here. And when you plug in your t is 9, you'll find your answer is 2. So meaning we are exactly at that point. And then you can plug in your t is 10. You can go in steps of 1. So from here, lucky enough, it's from 9 to 10. When you plug in your t is 10, in this expression here, what you will get is a 0. So meaning my function will be crossing here. However, my function is only bounded between t is 9 and t is 10. So I just need to draw a straight line coming down here, and I'm done. This gives you the same graph as what we obtained before. Do we have anyone who has a question? Should. Anyone who has a question? Okay, no problem. So let's quickly look at B. So for B, they are saying we need to sketch x of 3t. So meaning wherever you see t, go and put 3t. So we have two options here. Let's rewrite our, so let me see, wherever you see t, we will put 3t. So let's quickly go and rewrite our x of t, our x of 3t. So let me copy my x of t and put it just before this so that it will make my life to be easy. So here's my x of t here. I'm missing a 1 here. Let's copy our x of t and quickly do the sketch here. So that's my x of t. And now I need to do my x of 3t. So which means wherever you see t, make sure that you put 3t. So what we obtain there is 3t minus 2 into u of 3t minus 2 minus u of 3t minus 4, and then plus 2 into u of 3t minus 4 minus u of 3t minus 7, and then plus negative, where we see t, we need to put 3t. So negative 2, 3t plus 16 into u of 3t minus 7 minus u of 3t minus 8. Okay, so this is the expression which we end up having. In fact, the negative 2 and the 3t here, let me just make it right away to be minus 6t, and then plus my 16. Okay, so this is what your x of 3t would look like. And then you have two options here. You can either use the original graph or sketch this from scratch. So let's quickly take the original graph and see how we can modify it to fit this purpose or to fit this new change. So let me take the original graph, which is this one. Let me take it together with this one so that we see what modification is the 3t going to make. Okay, I'm not going to have enough space. Let me paste them here. And then let's erase the graph which we had here. Okay. Let's erase it. We do not need it. I just need the same axis. Okay, so what we are going to do is let's copy our expression. So there's one thing which I need as an answer from you. So when we do 3t, are we dividing the time by 3 or we are multiplying it by 3?
We are
Anyone?
dividing the time by 3.
So when we have 3t, this is the same as dividing the time by 3. Okay, that's what is going on here. So what we should do is you look at the graph. Every point, you will take the time and divide it by 3. Okay, so meaning you have exactly the same graph. All what you are doing is you are taking the time and you are dividing it by 3. So I'm gonna draw the same graph, but all what I'm gonna do is wherever I see t, I'm gonna divide it by 3. So I'm gonna draw my exactly the same graph. It's gonna go to here, and then to here, and then it is going to go down there because that's my original graph. It looks like this. Then wherever I see t, I divide it by 3. So meaning the new value, which is supposed to be here, where there was t is 2, it is now going to be 2 over 3. This coordinate will be that. And then this point here, for that point there, will now be at 4 over 3 as far as t is concerned. That point there, which was at 7, is going to be at 7 over 3. The point which was at 8, it is going to be 8 over 3. This point here, which was at 7 and 2, remember that we are dealing with t. The y value does not change. So here, remember the focus is only on t per se. So what we will do is we will, that point there, obviously the t is 7 over 3, and then the y value does not change. So your new graph would look like this after doing your time scaling. And then here, obviously, your x is RT. Do we have any questions? Anyone who has a question?
So when we multiply t by a constant or divide by a constant, the y value is always going to be the same. We just change the values on the t-axis.
Yep, because this is time scaling. Okay,
Perfect.
this is in quotes time scaling, meaning we are dealing with time there. That's our focus. We are stretching the axis or we are narrowing them if we multiply by a constant. The y value does not do anything. So it's more like all what you are doing is to the axis when you do time scaling. It's either you are stretching them or you are narrowing things. But the y value, they remain the same. Make sense? Okay.
Yes, thanks so much.
So let's quickly look at what then you would do for number C. So another alternative, which I'm not going to go until I finish. I'm not going to finish up this, but you would opt to do it exactly how we were doing it before. So you could alternatively, if you find the scaling and whatnot difficult, you can go the manual way. So the manual way would be, I come here, I draw my Cartesian plane. And then I look at this first part here. This function is bounded between. So here's how you do it. To find the boundary, you need to solve for t. So you need to take this, equate it to 0, and solve for t. That's how you'll find your boundary now when you have funny things like 3's in front of the t's and other numbers. So if you deal with that part and equate it to 0, whatever which is inside the u of t, for that part you will find out that you will get 3 over 2. So meaning that's the lower boundary. Then the upper boundary you will find as, when you solve for t here, when you equate this to 0, you'll find it as 4 over 3. So meaning this function here, this one, is bounded between these values. Okay, so we can now start looking for the value of the function. So the easiest thing which I suggest, you just substitute the boundaries. So if you substitute there on that function, you substitute the lower boundary, which is 3 over 2. No, it's not. It's actually 2 over 3. If you look carefully when you solve for t there, it is 2 over 3. So when you substitute 2 over 3, you have 3 over 2 over 3 minus 2. The answer you will get is 0. So meaning your function is exactly at 0 at the lower boundary. And then you can substitute then the upper boundary. So if you look carefully, you have 3 times 4 over 3 minus 2. And the value you'll obtain is 2. So if I put my 2 here, let's put the 2 here. The value you'll obtain will be 2. So meaning you are here. And then lucky enough, that's where your function is bounded. So we just connect the 2 lines like that. And then that's -1 problem with that function. And then we go for the second function. So you need to look at what I do carefully. This here, let me highlight it green. And then let's go for the second function, which is 2. So all what this is saying is our function is valued as 2, between which t values, we need to take this equated to 0 and solve for t. So when you have 3t minus 4 is equal to 0, your t will be 4 over 3. So meaning starting from 4 over 3, which is this point, until this here, which is 3t minus 7 is 0. So we obtain 7 over 3 as t. So meaning our function is, there's a value which is 2 between t is 4 over 3 and t is 7 over 3. So let's go and put 7 over 3 somewhere here. And our function at that point, it is still supposed to be valued 2. And that's the end. So we just connect those. And then now we go for the last part, which is, where's my pink, which is that. So what I said to you is, let's quickly look at where does our function start being bounded. So 3t minus 7 is 0, so we will have 7 over 3 as the first t, which is that point which we already have. And what I said to you is substitute those points in the function. So let's substitute -6 into the lower boundary point, which is 7 over 3 minus plus 16. And the answer you should be getting here will be -14 plus 16, which gives you 2. So meaning our function is at value 2 for t is 7 over 3. Okay. And then let's quickly go to where is it last bounded. So it is bounded between that and this. So meaning we need to do 3t minus 8 is 0, and we get our t as 8 over 3. So meaning it is bounded until 8 over 3. And then we take the 8 over 3 and substitute it there. So you have -6 into 8 over 3 plus 16, and the answer will be 0. So meaning at t is 8 over 3, the function will be here, and then you just draw straight line. And there you go, you are done. That's your function. Do we have any questions? Looks exactly like what we found before. So you see that even if you go the manual way, when you do time scaling, you do not affect the y value. Do we have any questions? Okay, silence is saying no, we do not have any questions. So let's quickly go to C. So our C, they're saying we should do x of t over a, where our a is 1 over, it's not 1 over, it is 1.5. And 1.5 is just 3 over 2. So if you look carefully, all what we are doing here is that we have x of t over 3 over 2. And what this turns out to be, it will turn out to be x of 2 over 3 t. Okay, so we have 2 over 3 p. And what we said before is that all what you do is you will divide your time by 2 over 3. So we're looking at the original function. Okay, so let's go and copy the original function and you will see what I will do. So let's copy that. This is when you start wishing in the exam you could go with your iPad or tablet and copy and paste things. So look at what I'm gonna do. This function here, which we have at the top, is our famous x of t. Now at the bottom, they want us to do this one. And what we know is that all what we need to do is to take the t value and divide it by the number which is here. The number which is multiplying t. So I'm gonna have the same looking function. The only difference is I'll go on the axis and divide these values by 2/3. So dividing by 2/3 is the same as, so when you divide by 2/3, it is the same as multiplying by 3/2. Okay, so I'm just gonna multiply by 3/2. So which means this point, which is here, the first point here, is supposed to be at a t value of 2 multiplied by 3/2. That's the t value. So meaning my t value there is just supposed to be 3. And then here I had a 4. So meaning I am supposed to have a 4 times 3/2. So which means here I'm just supposed to have a 6. And then here I had a 7, which means I have 7 times 3/2, which means the value which will be sitting there, it will be at t is 7 times that is 21. 21 divided by 2, 22. So that should be 11.5, I think. Okay. 11 plus 11. Nope. Can't be.
10.
It's
10.5. So that would be at 10.5. And then the last value, it would be at 8 times 3/2, which would mean it would be at t is equal to that divided by 2. This would make it to be a 12. So my graph would be looking so nice. I would just be having these values here. I would be having a 3 here, and then I would be having a 6 here, and then a 10.5, and then a 12 here. And the marker would be very happy with me. Okay. And then alternatively, you could do exactly what we did before. Where you see t, go and compute this function. Where you see t, you just put in 3 or 2/3t. And then you start finding the equation the same way we did here, and you will come to the same conclusion as we proved that we did it the graphical way here, and then we came the manual way, we still got exactly the same answer. Okay, so let's look at D. So D, if you look carefully, what they did there is time reversal. So for D, they are saying we should sketch x of negative t. This is AKA.
For B,
Yes.
did you compress the signal, and for C, did you expand the signal? Was B a compressed signal and C an expansion signal?
Yes, that's what is going on. So essentially, the smaller the value of A, you are compressing, not compress. Let me see, let me get something right. So when something is doing this, the compressing or sleep turned on, I'm not yet sleeping. So is this compression or it's expansion?
Should be expansion.
Okay, great. So the bigger the value of A, so meaning when we do x of AT, So the bigger A, or the bigger the value of A, what we are doing is we are compressing. And then the smaller you make A to be, for example, if you put A is 0.5, you would be expanding the function. So if you put A is 2, the function will appear, let's say, like this. Let's say, for example, you have a signal x of t. It is like this. It is at A is 2. When you do A is 0.5, your function could easily be something like this. Okay, I hope this helps. Let's quickly dive into our D and see how we compute our time reversal. So let's go and do our D here. So our D, our x of negative t, is also known as AKA as time reversal. Reversal. So when they say perform time reversal, all what they're doing is take the t, wherever you see t, put negative t. So let's take the original graph, very useful. And then wherever we see t, we will put negative t. So essentially, we just flip this graph. So let's go here and paste it here. So now what is going on here is wherever I see t, I'll take all these values and multiply the t's by negative 1. So let me draw a Cartesian plane here. It will obviously lean towards that side. So let me push it like this. And then let's quickly see. So when I multiply, for example, this point, so the y value, remember, does not change. So I'm going to put my 2 to be somewhere here. And then this would be that. So if you look carefully, when I multiply this positive 2 by negative t, I will end up negative 1. I will end up having negative 2. And then the other point will be negative 4. The other one will be negative 7. The other one will be negative 8. And then all what you do is you just multiply these t values by a negative, and then you resketch your graph. So if you think about it carefully, where's my blue? It is going to end up looking like this. The t is 4, it's supposed to cross there. So it's going to end up looking like this. And then where is the gray part? That is between t is -4 and 7. So that gray part will be here. Then the last part, which is the purple part, is going to go like this. Okay, this would be your time reversal. So essentially, when you are doing your time reversal, think of it as if you are creating a mirror. A mirror. Think of it that way, because if you look at the function which we have now, it looks like we have a mirror here and it's reflected on the other side. That's your time reversal. Do we have any questions? Okay, and then what we can do is let's quickly look at E. So for E, they are saying we should sketch x of the A is 3. So we have 3t minus 3. So the nice part here is that already we have the function for 3t. And all what we need to, for x of 3t, all what we need to do is to shift it by 3 units. So let's go and copy the function for x of 3t. Let's go up. Where is that? That's x of 3t. I want the sketch. There you go. So here, let me not forget to say this is x of 3t. So let's copy that function for the graph of x of 3t, and then we just paste it here. Because all what we do here is we already have 3t, and then we just need to shift it by 3 units to the right. Alternatively, you can go back to our original expression x of t, where you see t, substitute 3t minus 3, and then you do the solving as we would manually. But already I have the upper hand here. So which means all what I need to do, I'm going to duplicate exactly the same graph. Is that the only difference is I will change those points which I see there. So let's quickly drag this one down, and that one down, that point down here, and this point down here. Then we have a T. Then I put my 2 here. Let's put the 2 somewhere here. So all what I need to do is, because I have my 3t already, I need to shift every point to the right by 3. So which means what I need to do on all the t values of this graph, all the t values, I need to add 3, and then I'm done. So if we do 2 over 3 plus 3, what is the answer?
11 over
11 over 3. And then that one we will do 4 over 3 plus 3. Please give me the answer.
18 over
3.
Is what?
13.
1, 3 over 3. And then we do 7 over 3 plus 3. What is the answer?
16 over
16 over
T is that. T is that. So we get T is 16 over 3. Then let's do the last one, which is 8 over 3 plus 3. What is the answer which we get there?
17 over 3.
17 over 3. And then all what I need to do is to draw exactly the same graph, same amplitude, because I am well understanding that time shifting does not affect the amplitude. So my graph was as such. I had a point here and a point here. I need to connect them. And then here in between, I had another one. And then I had another one sliding to that. And there you go. This is our final graph. So here you have 17 over 3. And then when you go down here, you have 16 over 3. Then when you go down here, you have 13 over 3. Then the first point is 11 over 3. Then I can erase all of these as they make my graph to not look neat. And then the lecturer would be extremely happy with you. Do we have any questions?
So if we wanted an amplitude change, how would our x of t look? What change would we make to it? Does that make sense?
So for example, let's say they take, so the amplitude affects exactly the amplitude. So let me make f here and say they say do 7 x of t. So I'm going to take my x of t. Where's that function of mine, x of t? There you go. So I'll take my x of t, because now I'm changing the amplitude, not the time. I'm multiplying the whole function. I'll paste it here. And this here would be my x of t. So the 7 here, what it implies is that we need to change the amplitude. So which means my new graph is going to look exactly like the previous one. Let's quickly sketch it. So it's going to look like this. And then let me quickly take those values there, another one here, another one there, another one. So the time does not change because the focus is the amplitude. So I'm still going to have a 2 here, a 4 here, 7, and 8. And then my graph is going to look pretty much the same. The only difference is here I had an amplitude of 2. Now I have 2 times 7, which makes it to be 14. So I can put my 14 somewhere here. Then let's say draw a dashed line. Then I can start connecting my graph just like before. So a dot here and a dot here, and then we connect. And then we connect here. And then lastly, we go down there. So this would be how the graph would look like when we are just scaling up the amplitude by 7. Does this answer the question?
Definitely. Thank you so much.
Okay, no problem.
But
So, yes.
Can I ask, for this course, we don't do amplitude shifting, right?
You
Because
can. No, there's no amplitude shifting. It would be scaling. So you just change the
scaling.
Yeah. So I don't see a reason why they shouldn't include it. So genuinely, I think time scaling is much more complex than just scaling up the Y value. Because all what you do when you say time or amplitude scaling, you just multiply whatever which is here by the constant. And then you just make it to either widen up or narrow down. So I do not see it as something which should be so complex such that if it comes out, there would be any case which you guys would have for not being able to do the question. Because it is just multiplying the Y value by 7. That's what we did here. We moved from a 2, because we had a 7, now we have a 14. The T values are still the same because we are doing an amplitude change or an amplitude scaling. Do we have any other boiling question?
Would we ever need to shift the graph up or down?
No. Nope, I don't think they will. But if they do say you should shift it up, I think it's something which is easy to do, because when you shift it up, all what you are doing is you are changing the Y value. So for example, let's take our x of t. And let me say this is example G. So if they say take your x of t and add, let's say 10, what I'm going to do is I'm going to take my graph of x of t. So really there's cases which I genuinely think there is no need for them to teach it because it makes common sense. So for example, our shift of 10 would need to be, let's throw that and come here. So let me quickly paste that because time does not change. Paste that and that one. So my time is still the same. We have a 2, a 4, a 7, and 8. So when they say we need to shift the graph 10 unit up, it means every point I must take it up by 10. So meaning what I can do is this point here, which was that one, I can take it up by 10. So let's say our 10 is somewhere maybe here. That's where the 10 is. So that point is now going to be a 10. Then the other one, if we take it by 10 units up, it is going to be at 12, if you think carefully. So it is just going to be somewhere here, but at 12. Let me think. It is 2 units up, the other one. Yes, it is going to be at 12. When we shift every point up by 10, you only change the y. So if the y was 2 here, when you add 10, it becomes 12. And then it comes here, and then the last point will be here. So my new graph would look like this. Goes there, and then it goes down here. And this graph here would be your x of t plus 10, meaning shifting it by 10 units up. So I've never seen these before, but it makes common sense that they are doable and they are easy because it is good as doing your shifting up and down, which you were doing on your cosine functions back in high school. Do we have any questions? Any other boiling question? Okay, another round for questions. There are none questions, or if there's no question, then we can wrap it up and call it a day. The last round for a question.
Sir, I have a question regarding the power from that one. So I did it using the shortcut method where you just say p is equal to a squared over 2. Instead of like where you have to FOIL it and then work with your trig ratios and all of that. And I still got the same answer. Am I allowed to always use that method and would I get full marks?
Okay, so you got the same answer as, was it the average power or the actual power?
It was the power. It was. I sent a picture to SETMind admin on WhatsApp.
So my question is, if you remember earlier, we said there's power, which you should use the formula P is equal to, if the function is periodic, then you can easily resort to using this as a formula. And then I said, if the function happens not to be periodic, then you should do this 1 over t, the integral of, we can still take it here from negative pi over 2, not pi, sorry, t over 2 x of t squared dt. So my question to you is the power for the same question we were doing earlier. If you remember that integral, did you finish it and you got the answer for that integral? And then you started using the power where they speak about half the amplitude squared. And then you got the same answer.
Yes, so I just wrote out the integral and then because it was squared, I wrote out my 2 brackets and stuff. And then I just used the p is equal to a squared over 2. And I took the amplitude, squared it and divided it by 2. And
Okay.
then I subbed in my trig. Also I had to find my limit of integration. So I just said 2 pi divided by what was inside the bracket. And then I got the same answer, yeah.
Makes sense. So essentially you're looking for the period, which would be the common factor.
Yeah, that's what I did. And
okay,
then from that I looked for the LCM and then I took that to be the upper limit.
Okay, no problem.
0.
So here's what I'm gonna do. I'm gonna have a chat with the admin and see if I can look at your solution. And then what I'm gonna do afterwards is write something as a note, which it should be shared with you and the rest of the class regarding power and energy signal. So I would need to see what you did. So I will check what you did. So is there any other question?
Okay, thank you so much.
Hey,
So
no problem.
I just wanted to ask quickly, just going back to mechanical systems that we did in the previous session, is the mass
Yes.
spring damper system like the only mechanical system we should try and look at and understand?
So it's the most complex one, but there's nothing more complex than that. So maybe you can be lucky and get a spring mass system, which would be the easiest thing. But take it as if you know the spring mass damper system, then you are sorted. And then if you know your RLC circuit, you are also in good shape.
Okay, perfect. Thank you so much.
Any other question before we conclude?
For the RLC, do they normally only ask it in series, or can they ask it in parallel?
They can ask it in parallel, and what that would mean is that you need to use your KCL instead of your KVL. So remember that when they are in series, it is the current which is the same. So that's why we try to write everything using KVL, and then we try to solve for the current because it's what makes them to be common. But then if they put things in parallel, what makes them to be common is the voltage. The voltage across the inductor, the capacitor, and the resistor will be the same. So meaning your aim would be, depending on what they consider as Y, you would want to write everything in terms of that voltage. And all what you need to do is relate the voltages, and then believe me, it's extremely easy. Just that I have not come across an example where they have things in parallel from your previous test and your previous exam. Okay, any other question? We are going in 10. Any other question? It's not going to start making sense after the session. You have an opportunity to ask. Okay, if there's no question, then I think we can call it a day. So all the best on your test, and hopefully you will get those 80s and 90s. So believe me, it is possible to get a clean 100 in signals. You can ask me how. I do not know, but I assure you that it's possible. There's certain things which you should see, and then you'll start believing it's possible. But you can easily get 100. Getting a 90 is extremely easy. It's one of the easiest courses I've ever seen. Anyway, let's conclude.
So one more question. I just want to make sure when we working with instantaneous and dynamic systems and causal and non-causal, we just take any value for t, like we can take 1, 2, or 3 subroutine and see if we get the same outcome from our left-hand side and right-hand side.
Yes, that's what you do, because you'll be having whatever system you have, be it a differential equation. For what we are expecting is that our y of t will produce, or an x of t will produce y of t. So for this kind of system, this would be a system which is memoryless, and also we would call it your instantaneous. And then if, for example, you just give it a try, what you would usually try is just take any t value. So let's say you look at maybe t is 2. And then your x of t of 2 gives you, let's say, for example, y of 4. Or let me, in fact, switch it and say, when you put t is 2, your y of 2 becomes, let me say, x of 1. This we spoke about earlier. So this would be a problem because you are not getting x of t for you are not getting y of 2 being equivalent to an input, which is x of 2. So this system is what we would refer to as a system which has memory. And if a system has memory, what we will then say is that the system is dynamic, because what this would mean is that for every y of t, my input is x of t minus 1. And already you can see here that we can then speak about causality and other issues. But the question is, or maybe, does this answer your question?
Yeah, so it's only these two that you sub in a value. For all the other systems, you have to work it out with a different method.
Yes.
Okay, thank you.
Okay, thank you.
So as a closing question, would this system be causal or not? This one. Whatever which is going on, would this be a causal system or not?
Causal.
Why would you say this is causal?
Isn't it because when you sub in a value for x, for example, if x is 0, well, if you sub in for t is 1, x is going to be 0, and then y is 1. So therefore, your input, your output depends on a past input value.
My output depends on the previous input. So for that reason, this would be causal system. So as long as it depends on a previous, or as long as it depends on the current or previous input, then it's going to be a causal. It becomes non-causal if it depends on the future input. So meaning when you change there and put a plus, the system would be non-causal.
So can I ask one more question regarding causal and non-causal? What happens if we have like a case, like the one example we did in the lecture, it was like y of t equals x of minus t. And when you sub in a value for t equals 0, then a value for t equals 1, then a value for t equals minus 1, you get a current, a past, and a future. So which one takes like the most priority? Is it future or not?
No, it's not. It's not. So so I need you to think of it carefully. So you said y of t corresponds to x of t minus what?
So x of minus, it's just x of minus t.
X of minus t. So what does that mean? X of minus t, what do you mean?
It was just the one lecture example we did. It was the first lecture example we did on causal and non-causal. And her answer was non-causal. So judging by the working out, so when you sub in t equals 0, you get y of 0 and x of 0. So that's obviously present.
So let me quickly do this. So if we put in y0, yeah, we would get x negative 3. If you put y1, we would get x is minus 2. Then if you put y2, I would get x minus 1. Then if I put y3, I would get x 0. And then if I put y4, I would get x 1. So look at what is going on here. You don't need to substitute a lot. So think of it as if you are the output. So the output ideally is saying, if I'm evaluated at 4, I'm expecting my input to be evaluated at 4 also. But my input is lagging behind. It is at 1. So meaning I'm at 4, but my input is still remembering things which are at 1. So this system here, number one, we can say it has memory. Because Y is saying I'm sitting at 4, and I'm expecting my input to be sitting at 4, but it is at 1. So which means my system has memory because it's lagging behind. And for that reason, this cannot be instantaneous.
Okay, perfect. What I was asking is the one example we got in our lecture.
System.
It was y of t equals just x of minus t. So it wasn't t minus something. The actual t that was in the x bracket is a minus. So what I was saying is when you sub in a value of -1, 0, and 1, you get all three conditions of past, present, and future.
Mm-hmm.
And
So
her
there
answer
was-
was non-causal. So I'm asking, can we just come to the conclusion that if you have a system that we're evaluating and we get the condition of past, present, and future, does future take preference over them? Thus, we conclude it's a non-causal system.
No, the problem is I'm failing to understand what you mean when you were saying there were all conditions were ticked, because a system, because if you remember, a causal system, it is one which its output can depend on current and previous input. The non-causal is dependent on future input. So for example, this one, the current output is dependent on a previous input. So this would be a causal system.
Okay, yeah, I understand. Can you maybe do the example? It's just y of t equals x of minus t, and see what I'm trying to show you. Maybe it's better to just see it visually. Thank you so much.
So y of t is what?
X of minus t.
X of minus t. Okay.
And what I was saying is we sub in values of -1, 0, and 1, and then we'll see what conditions we get.
Okay, so you are saying we should do t is -1, and then that would make my x of 1. And then for 0, I will obviously get that. And then for -1, I would get x of 1. So let's stop here. Is it okay?
Yeah, that's perfect.
Okay, no problem. So let's quickly see what is going on here. So if we increase y in the negative direction, x is increasing in the positive direction, and if you increase.
So the third one should be 1, y of 1, and x of -1.
Let me quickly look at what you are saying. This one here.
Yeah, the third one. It should be 1, y of 1, and x of -1.
So y of 1, let's quickly fix that. Y of 1 and then x of -1.
Yeah, like 8.
Okay, let me put y of 2 here, and I'll have x of -2. So let's quickly look at what is going on. So our output at 2 is dependent on our input at -2. So if you look carefully here, current input is dependent on a future input. So if you look at, I see what you are saying now. If you look at y here, the current input for the current y is dependent on a future x. Does it make sense?
Yes.
So if you look at this expression carefully, the current y is dependent on a future x. And then when we get here, it becomes a causal system, or it becomes just instantaneous. Then when we get here, the current y now depends on a previous x. And as we go up, the current y is dependent on a previous x. Okay, I see. And then what conclusion did we end up coming with here?
The memo in the lecture said that it was non-causal because because as we increase now in the positive direction, so if we say y of 3, we'll see that it still happens in the past. But when we make the t value smaller, so if we make it y of -2, we'll see that it becomes future. It will become a future trend. So can we make a conclusion that future takes preference over past and present? Or
I think that's what we will need to take away, because if that's what you gave away, because what I'm picking up is that the system can be both, depending on where you are heading with your T. So let's just make a generalization. I think you can check with some of your mates that if the system has for different T's, or if the system for different T's can behave as causal and non-causal, then we will conclude that it is non-causal. If the system behaves as both causal and non-causal for different T's, then the conclusion, I will think of this also. And then if I end up thinking otherwise, I'll drop a text. So then the conclusion is the system okay. Any other question?
Will a dynamic system always
I think what
you can give it a try. You disturb one another. Let's take the first question. Would a dynamic system be?
Will a dynamic system always be causal and an instantaneous system always be non-causal?
Let me see. Dynamic system, would it always be causal? Let's quickly go to where I wrote memoryless and dynamic. Where is it? Okay, so a dynamic system, please repeat what you said. I want to pick up specifically on the dynamic and causal.
So a dynamic system has memory and an instantaneous system is memoryless, right? So will a dynamic system always be causal and an instantaneous system always be non-causal?
So a dynamic system will always be causal.
So then an instantaneous will always be non-causal.
Let me think. Instantaneous, it is dependent on the current T. I think it is case dependent, because remember that instantaneous, what we are saying is that for every shift in the input, there's an equal shift on the output, meaning the current output is dependent on the current input. So that would make it to be a causal system. So my suggestion is do not try to lump those and make them the same, because I can't think of a case now which would make them to differ. But at the same time, I'm scared to say if a system is dynamic, then it means it is non-causal, and otherwise. I think look at what we said earlier about dynamic systems, and then you also look at causal systems separately. Because
Okay,
maybe
so
there's
let's say dynamic, causal, instantaneous, non-causal.
Yes, but my takeaway is that please look at the system separately and do not conclude by just looking. I can't think of a case which would make it to be false now, because all the cases I'm thinking agree with what you are saying, but at the same time I'm careful not to agree as a whole, because maybe there's a case which I haven't thought of. Okay, any other question?
So just a clarification, when we spoke about power and energy signals, you said for power signals, many of them are periodic. And then for energy signals, many of them aren't periodic. By saying many, can we just assume that power signals are going to be periodic and energy signals are going to be non-periodic.
Yep.
Perfect. Thanks so much.
Anyone else? Okay. Silence is saying we are all in good shape and we are fit for the assessment. So I suggest we work through the other questions. So I saw the tutorial 2, which was shared, and it is easy. They said 0 input response, take the right-hand side and equate it to 0, and then start solving the homogeneous differential equation, apply the initial conditions, and you are done. And then tutorial 3, I saw it's an RLC circuit, which we have done, so that should be easy things. And I saw that they also have things like BIBO, stability, testing time invariance, which we did. So I hope if you review the previous session, I'm assuming the recording should be up now. As time I spoke to the admin, I think recording 1 was up. So recording 2 should be up very soon. So please make sure you review that and you get up to speed with proving those things like your BIBO stability. But in a nutshell, remember our x of t, preferably choose it to be bounded. Mostly it should be a step function. And then for that step function, you will check if your output will always be bounded. And there you go. You have proved if your function is BIBO stable or not. Then linearity, it's what we're doing in calculus. Time invariant, we do a shift on the x and see if it will cause an equal shift on the y. If it does not, then we conclude otherwise. So if there's no further questions, I think we can call it a day. You can rest and then wake up early in the morning and grind for your life. So thank you.
Send this document tonight, please.
Yes, I'm gonna share this. So it's gonna be shared in the groups as soon as I finish here.
Thanks so much, sir. You've helped so much.
Okay, no problem. So good luck. I think the next time we'll chat is when we are doing maths in prep of the coming test. So cheers and thanks for attending. I think you should thank yourself for doing that. Otherwise, we can call it a day and then we will chat when we do maths. Good luck.